All right, today we're going to unravel this fantastic mathematical puzzle. It's got everything: a royal fortune, 100 lockers, and a prince who has to be clever to win it all. You'll see how solving this riddle actually reveals some really beautiful secrets hidden inside a special group of numbers.
So picture this. Our story starts with Queen Ratnamanjari and her son Koisnam. The queen has passed away, and she's left behind a huge inheritance. But there's a catch. To claim it, Koisnam has to solve a challenge she set up for him and his 99 relatives.
And I mean, the stakes could not be higher. The Queen's will makes this a total winner-take-all game. Koisnam has to be the very first person to crack the code if he wants to see a single cent of his mother's fortune.
So what is this puzzle? What's standing between Koisnam and all that money? Well, it all takes place in a room full of lockers, and the rules are pretty specific.
Okay, so here's the deal. We start with 100 lockers, and they're all shot. Then, 100 people numbered 1 to 100 are going to walk by. Person number 1 goes and opens every single locker. Then comes person 2. They go to every second locker, so 2, 4, 6, and so on, and they toggle it. And toggle just means they switch its state. If it's open, they close it. If it's closed, they open it. Person 3 does the exact same thing for every third locker, and this whole thing continues all the way up to person 100. And that's it. That's the whole game. So here's the million-dollar question. After all 100 people have had their turn, which of these 100 lockers are going to be left open? The answer is the key to everything.
To crack this, we gotta think about who is touching which locker. A person only toggles the locker if the locker's number is a multiple of their own number. Or, let's flip that around. A person touches a locker if their number is a factor of the locker's number. And that right there, that's the secret.
And this is where the pattern really starts to jump out at you. Take a look at locker number 6. It gets toggled by people 1, 2, 3, and 6. That's 4 toggles, an even number, so it starts closed, gets opened, and finally closed. But what about locker 9? It's only touched by 1, 3, and 9. That's 3 toggles, an odd number, so it ends up open.
So there it is, the big secret. The number of times any locker gets toggled is exactly equal to the number of factors it has. A locker will be left open only if it gets toggled an odd number of times, which means it has to have an odd number of factors.
But that just leads to another question, right? We know the open lockers are the ones with an odd number of factors, but why? What kind of number even has an odd number of factors to begin with?
And this slide, wow, it just lays it all out perfectly. For most numbers, like 6, factors come in nice, neat pairs. You have 1 times 6 and 2 times 3. See? Everybody's got a partner. That always gives you an even number of factors. But look at 9. You've got 1 pairing with 9, but then you have 3 pairing with itself. It's a lone factor. And that's what makes the total number of factors odd.
And just like that, it all clicks into place. Koisnam figures it out. The secret isn't just about factors, it's about a very, very special kind of number.
They're called square numbers, or you might know them as perfect squares. They're what you get when you multiply a whole number by itself. And because one of their factors pairs up with itself, like 3 times 3 equals 9, they are the only numbers that have an odd number of factors.
And just like that, we have our answer. It's so elegant. The only lockers that will be left open are the ones whose numbers are perfect squares. So that's 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Koisnam knows the answer.
But hold on, we're not done yet. The Queen left one more little clue. Knowing which lockers are open isn't quite enough. Inside, there's a final note about a passcode. And the passcode is made from the first 5 locker numbers that were touched exactly 2 times.
Okay, so a number that was touched exactly twice. That means it has exactly 2 factors. Well, what's that? That's the definition of a prime number. Their only factors are 1 and themselves. So the first 5 prime numbers give us the passcode: 2, 3, 5, 7, and 11. And with that, the puzzle is solved and the inheritance is his.
So, Koisnam gets the fortune. Puzzle solved. But let's not stop there, because these perfect squares have some other really cool patterns hidden inside them. They're way more than just the answer to a riddle.
Okay, first up, here's a really cool trick you can use. You can often tell if a number isn't a perfect square just by glancing at the last digit. Every single perfect square has to end in one of these 6 digits: 0, 1, 4,
5, 6, or 9. So flip that around. If you see a number that ends in a 2, a 3, a 7, or an 8, you know right away, 100% for sure, that it can't be a perfect square. It's a super handy shortcut.
Okay, get ready for this next one because it's really beautiful. Every single perfect square is simply the sum of consecutive odd numbers, starting all the way back at 1.
Just look at how this builds. It's incredible. 1 is just 1 squared. Add the next odd number, 3, and you get 4, which is 2 squared. Add the next one, 5, and you get 9, 3 squared. Add 7, you get 16. The pattern just keeps going, perfectly, forever.
You know, this kind of beauty isn't just limited to square numbers. The whole world of numbers is filled with these amazing patterns. So let's take a quick look at their cousins, the cube numbers, and meet a man who saw numbers in a way nobody else ever has.
This is Srinivasa Ramanujan. He was a mathematical genius from India, largely self-taught, whose insights just stunned the greatest mathematicians in the world. His colleague once said that for Ramanujan, it was like every single number was one of his personal friends.
And the story goes that one day, another famous mathematician was visiting him in the hospital and mentioned that the number of his taxicab, 1729, seemed like a pretty boring number. Ramanujan, from his hospital bed, immediately said, "No, it's a very interesting number."
He knew, instantly, that 1729 is the smallest number that you can express as the sum of 2 cubed numbers in 2 completely different ways. It's 1 cubed plus 12 cubed, and it's also 9 cubed plus 10 cubed. It's just this perfect little gem of number trivia that makes you wonder, what other secrets are just waiting to be found inside the numbers that are all around us every day?